Welcome COP 1000 students. This is Module 3. We're just going to discuss some computer terms and definitions. Number one is hardware. Hardware would be the physical components of the computer system, your monitor, your keyboard, and so on. Software is the intangible part. It's the code we write. We can't like hold it or feel it, but the computer can execute the statements in the software instructions. Memory is where information is stored. RAM is temporary memory. When we unplug it, everything there is gone. ROM, on the other hand, stands for read-only memory, and ROM is a piece of the memory where we cannot write information there, but we can read from it. We don't really use ROM. The computer uses it during startup. There's some instructions there for the computer to get started. Storage is permanent, where we permanently put information. We can store information in storage devices, unplug the computer, and we don't lose anything. A compiler is a software program that is used to take our source code, the code that we're going to write, and convert it into executable code. While it does this, it's going to identify what's called syntax errors, or maybe you might want to call it grammar errors, as it converts our code into something the computer runs. CPU is nothing but a physical device. It's a chip, central processing unit. It's where all your calculations and sortings take place. If I compared this to a person, it would be the brain. A computer programmer obviously is the person that writes the software. A computer programming language is the tool that the programmer uses to write software. Many different languages out there: Java, Ruby, C#, PHP, Perl, Visual Basic, C, JavaScript, Python, Objective-C, C++, and Go. Valencia, we teach Java, we teach C#, we teach C++ and C. I don't believe we teach Python, which is why I'm going to be using Python in this course. Source code, that's the code that you can understand. It's the code that you write. We use a text editor, text document, or a IDE to create it, but it's the part that cannot be understood by the computer, but it can understood by us. Text editor, why would I talk about a text editor? Because all I need is any old text editor to write source code. Even though that's all I need, I don't want to do that. I want to use what's called an IDE to write my source code. Software development life cycle, pretty important stuff here. Software development life cycle, it's a cycle, so it starts at the top and it's cyclical, and it ends back up at the top. It begins with a problem. We take the problem and we understand it. Then we use design tools to design it. Then we eventually take the design and run it through, or use an IDE to write the code. We test, debug. During any phase, we can go back up to the top. And eventually we get code that runs. We implement it at the client's site. And then hopefully that client needs updates and maintenance so we can get paid some more. Again, my design tools are tools used by a programmer to map out or design software. There's 4 of them: PseudoCode, IPO Chart, Flowchart, and Structure Chart. IPO Chart is nothing more than the letters I for input, P for process, and O for output. I list my input variables, I talk about my equations, and then my output. PseudoCode is one of my 4 design tools. It's nothing but English-like statements, doesn't follow any kind of rules or anything. It's just do this, do that, do this, do that. Flowchart uses these fancy little symbols to create a diagram that represents the flow of the program. And a structure chart is more like an organizational chart. This is the top of the hierarchy, and these are all on the same branch, and then I can have things underneath each of these. Talk about all those throughout this semester. Talk about the term input. It's the stuff, information that goes into the computing system. In this course, most of it's going to be from the keyboard. Output, it's information that comes out of the program or the software program. We take data in, we do something with it or process it, and then we output it. We'll talk about comments. Comments will be placed in your source code so that people understand and you understand what you're doing. Comments and white space is ignored by the compiler. We'll talk about two different types, a single line comment and a multi-line comment. We're going to talk about functions or methods. Python kind of has both. Some languages call functions functions, and other languages call what we're going to call a function or method. What it is a block of code that performs a single task. We have built-in functions built into the IDE libraries, and then we have programmer-defined functions. All functions have a name followed by a left and right paren, followed by optional things inside there. We'll talk about that throughout this semester. Variables. Sometimes during execution of your program, you're going to need to store information. In RAM, you're going to store that information inside a variable. A variable is special because the value can vary or change. Variables have a name, such as hourly rate, hours worked. We're going to write our variables and our functions using camelCase. camelCase is a standard naming convention. camelCase is where we take the first word, all lowercase, all words lowercase, except starting in word number 2, and each word thereafter in uppercase. Everything lower, starting with here, then the next word, first name, uppercase, last name, uppercase. About this crazy variable, average weight of the dogs. Lowercase, uppercase, lowercase, uppercase, lowercase, uppercase, lowercase. Up or down, lowercase, capital letter, and so on. Order of operations, the computer follows what hopefully you already know, which would be order of operations. Anything in parentheses first, raising to a power, multiplication, division, left to right, addition, subtraction. A logic error is, well, if I think this equals 20 because I don't follow order of operations, that would be a logic error because this actually equals 10. It's not. 2 plus 2 is 4 times 2 is 8 plus 2 is 10 times 2 is 20. No, it is 2 plus 2 is 4, 2 plus 2 is 4, 4 plus 4 is 8, plus 2 is 10. A syntax error would be like a grammar error. We need to follow the rules of the language. We're going to learn the rules of the Python language, and we're going to have to follow them. If we don't follow them, the code's not going to run. We're going to talk about sequential programming, where we start at the top of a piece of software program that we write, and we just keep moving downward until the program ends. We'll talk about selection or decision, where we start at the top, we move downward, we hit this selection or decision statement, and we either execute a statement to the left or the right, never both. Repetition is where we start at the top, we hit a block of code, and we continue to repeat that block of code while some condition remains true. We'll talk about a special type of repetition that's typically an error. It would be this repetition or loop that never ends. We'll talk about conditions. Conditions are used in decision statements and loops. A condition is something that will either evaluate the true or false every time, true or false. We'll talk about conditional operators used to join two conditions or more together. There's 3 of them, and or not. Here are relational operators. There are 6 of them. These are used to build a condition which equates to true or false. Equals, notice it's not a single equal sign, but it's a double. Equals, not equal, less than, greater than, less than or equal to, greater than, equal to. Desk checking, we're going to take our design tool and we're going to sit down with a pen and paper and we're going to trace various inputs through it to make sure we get the desired output. Testing or debugging, once the program is written, we're going to run it over and over again using various inputs to see if we get the expected output. In this course, we're going to talk about binary and hexadecimal numbers. A binary number is a series of 1s and 0s, or base 2 number. A hexadecimal number is typically used for an address of data on RAM, whereas the computer stores our information as a binary number. A hexadecimal number is a base 10 number, where I have the digits 0 through 9, and then 10 is A, 11 is B, 12 is C, 13, 14, and 15. Summary. Make sure you study these terms. It is important that you speak this language, or you know how to speak these terms with ease and confidence. The terms in this presentation will be used throughout this course and throughout your career. Okay, that is 9 minutes and 38 seconds. See you in the next module.